Let me go over the agenda. First item is I'm calling it the prime directive. That will be explained in just a minute. Then I'm going to do a quick recap, not what's gone before the entire session, but just place of where people should be, might be. The main focus tonight will be going over Python primitive data types and operations. And then we'll spend some time coding in Python. That's going to be the primary activity of these sessions. And then next steps for the coming week, and then followed by a little bit of time for a Q&A. Also in the channel, I posted the link to the Discord Python Jedi Discord community, and really encourage everyone to join up there. Will be our primary mechanism for communication. And if you need assistance, also if you want to help other people out with Python, that's the place to be. Okay, recap. So we've sort of structured this learning activity as a series of missions. And where you should be now is you should have completed mission 1 and mission 2. Mission 1 was to install and verify that Python is on your local machine. Second, install VS Code. That will be the environment that we'll be using. And so you want to have completed those 2 missions. And of course, there's time and you can catch up, but that should be your first 2 missions, first 2 objectives. And then this coming week, I'll probably post this tomorrow or the day after, will be to write 3 fairly simple Python programs, and they will test out some ideas, and so I will assign those in the next 48 hours. And so your mission this week is to work on those 3 Python programs. Okay, so tonight's session, our primary topic will be primitive data and operations, and we're going to kind of take a step back a little bit. One of the things that I find is that people often kind of skip the fundamentals. They move on and they start programming, but they don't really have a grasp of the fundamentals. And so we want to kind of take a step back and see Python from the ground up and how it was sort of built out. And this is sort of an imaginative exercise. So Guido von Rossum created Python circa 1999, 2000. He'd been working on it for a couple of years, but this it came out about 20 to 25 years ago. All right, so this is Guido von Rossum. All right, so what we're going to try to do in the next week or so is not take on the entire Python world, but just a subset of that, a foundational level, right? Think of it as Python. Guido is a creator. He's going to create the Python world. On day 1, what does he do? Right? He's not going to create everything, but what does Python or Guido create on day 1? Well, atoms. So we begin with atoms, and the term in Python is going to be primitive data types. All right, so genesis of Python, we first begin with atoms, and we're going to use the term primitive data types. And so Python has 4 primary atoms, primitive data types. What are those? Integer, float, string, and Boolean. Just as an aside, this is the kind of thing that you should know and have ability to recall. This is the kind of material that you shouldn't have to look up, right? So if you walk into a cocktail party and someone asks you what you do, you say, I'm a Python Jedi Knight. And if they ask you a question, a pop quiz during the cocktail party, I'm sure it happens to you all the time. What are the primitive data types in Python? You should be able to just spit it out: integer, float, string, and Boolean. By the way, I'm not telling the complete truth. There are in fact two others. There's complex. Those of you know what complex numbers are in engineering or mathematics. That's also a primitive data type. And then there's another one called none. So just for the sake of completion, there are really 6. But we're going to only deal initially with these 4. And you really should have a good grasp of these 4. All right, so integer, float, string, Boolean, those are the 4 atoms in Python, the 4 primitive data types. And let's just look at some examples of that. So what's an int or integer? Well, those are integers, positive and negative whole numbers, including 0. So examples are 2, -11, 1, 2, 3, 4, 5, etc. And there's a unlimited number of integers that are available to you, given restrictions of hardware and so on. But as a data type, as an atom, int and integer is one of the fundamental primary data types. The second one is float. And what's a float? It's a decimal number. So integer is a non-decimal number, and a float is a decimal number. And examples of that are -3.14159, 11.23. So anything that has a decimal is a number, and it's of data type float. So we have 2 primary numerical data types in Python, int and float. Then the third fundamental data type, primitive data type, is a string. And strings are examples of that are alpha and beta. This is really a character data type. Now, some of you are familiar, likely be familiar with other programming languages. And in programming languages like C, you have a char data type, which is just a single character. But Python, there is no char, it's a string. And a string can be a character of any length. We'll see later on that string, you can form a string either using 2 quotes, starting with 2 quotes and ending with 2 quotes, or a single quote also, and start with a single quote and end with a single quote. Both are valid representations of a string. So that's the third data type. Just like integer, float, string also, there's uncountably many strings that you can form. Just given the only limitation is hardware representation of a string. But in terms conceptually, it's uncountably many, infinite number of integers, infinite number of floats, infinite number of strings. Then the final primitive data type, final atom of Python is a data type called Boolean. Its shorthand is bool, B-O-O-L. And Boolean is a enigmatic data type. You'll see how it works, but there are only 2 possible values of the data type Boolean, true and false. Now, one thing to note here is true and false are not the same thing, and we'll see that, we might have seen that last week, is not the same thing as the string true or the string false. Okay, there's a data type whose value, a data type Boolean, who only 2 possible values, true and false. So in summary, these are the 4 primitive data types in Python that you need to understand and master. Okay, then once we have the atoms or the primitive data types, we perform various operations on those data types. On the numerical data types, integer and float, we have addition, subtraction, multiplication, division with single slash, exponentiation, which is performed with 2 asterisks. Then we have something called floor division, and then the modulus operator, which gives you the remainder when you're dividing 2 numbers one into another. with string primitive operations, there are two, plus, and it's called concatenation. You're adding one string with another one, and that's called concatenation. The way we do that is using the plus sign. And with strings, we can also use the asterisk as an operator. And if it's performed with a number like 2, it will generate consecutively n number of strings. And you'll see that in operation. Boolean, there are 3 primary logical operators: and, or, and not. There's some other representations of that, but the 3 primary operations, logical operations, you negate Boolean. So if you operate on the true, you'll get back false. And if you're familiar with truth tables, you can use and, or, on various combinations of true and false. All right, so summary: Python, it gets created by Guido von Rossum, the world of Python, and there are 4, now I'm going to use the word objects now. There are 4 objects, primary data objects: integer, float, string, and Boolean. We perform various operations on those primitive data types, and those are going to be the building blocks of computation as we kind of build things out. All right, so now let's kind of switch gears. Let's go into Python and take a look at this and put together some other ideas. Okay, so I'm going to go into VS Code. All right, so you should be familiar with VS Code, at least from a beginning standpoint. I've just opened it up. I have the Welcome tab. I'm going to click that off. And then the next thing that I usually do is open a file or folder. So I'm going to open a folder, and right now I'm going to open a folder on my desktop called Intro Python. Okay, and it's an empty folder. You're able to create a new folder if you want to, but you should decide beforehand where you're going to store your Python files and navigate to that. And if you need to create a folder for a project, create that folder when you use the open command. Okay, so now I'm going to close this tab again, and this is a fairly standard look at the opening screen for VS Code. And it shows me under Explorer that I'm in the directory called Intro Python. If I look at the terminal window and I type ls for listing directory, it's an empty directory. If I type pwd for present working directory, it shows me the path. So in my computer, there's a folder called users. Underneath that, there's Galois. That's the user desktop. And then Intro Python is the folder. So this is where I'm currently in my file explorer. Okay, so now let's create a program, Python program. And one way to do that is to click in Explorer where it says New File. It has a plus symbol. I'm going to click that, give a name to the file, and I'm going to call this program area of circle.py. And if I type .py and give it the extension and hit return, VS Code intelligently detects that you're about to type a Python program or a Python script, and it will highlight certain things. It will automatically help you indent things, and it will bring up something called IntelliSense to help you out with the environment. Now, this assumes that you've installed a Python extension, which was explained a session or two before. Okay, so I'm ready to type a new Python program, and typically it's good practice to start your program with a comment. A comment is not an instruction, but it's basically just an annotation to yourself and others who are going to read the program. So we're going to say this program calculates the area of a circle. Okay? All right, so we're going to write a program to calculate the area of a circle. And next line, we're going to assign a value to pi. Okay, so area of a circle, the formula, what's the area of a circle? The formula is area of a circle is pi times radius squared. Okay, so we need pi. Pi is a constant, but we need the value. Now there are ways to retrieve the value from in Python, but we're going to just manually assign a value to pi. And I'm going to explain. So we're going to create a variable called pi, and I'm using uppercase, and I'll explain that to a minute. Usually by convention, you want to use lowercase letters whenever you create a variable. Right? So, but pi, which will be a constant. So what's a constant? A constant is something that the value is never going to change, typically shouldn't change within your program. And that's a constant. The value is going to stay the same. So that's why this is by convention. I could use pi lowercase as a variable name, but since the value of pi is not going to change, will not change, I'm going to use uppercase pi. So I'm going to assign 3.15, I think it's 9, as the constant value for pi. Okay, next we're going to assign a value to the variable radius. So we're going to create a variable called radius, and that will be the radius of the circle whose area we want to calculate. And for starters, let's just assign the radius 1. We will change it a little bit later on. Okay, so now I have pi, and now let's calculate the area of the circle. And so we're going to create a new variable called area, and area is pi times the radius squared. Okay, and now let's print the area. And so I will use the Python function print. And what do we want to print? We want to print the value, the calculated value area. Okay, so let's just pause here and go over first line of code. We assigned a value to the variable pi. We made it uppercase because it will be a constant. Its value will never change. We created a variable called radius, and we assigned the value 1. Then we calculate the area of based on the value for pi times radius squared. Now, one thing to note here is when it calculates pi times radius squared, it doesn't go sequentially. It doesn't. Area will not be calculated by taking pi, multiplying it by radius, and then raising that to the second power. There is this rule, I think its abbreviation is PEMDAS. First, and it indicates, this is from algebra, the order of operations. PEMDAS says, okay, if I have parentheses, I'm going to manipulate whatever's in the parentheses, then exponentiation, and then multiplication, then division, and addition, subtraction, right? So that's the order of operations. So we don't have any parentheses, so we do have exponentiation. So it will raise the radius to the second power first, and then multiply pi times that. Now I always get I forget PEMDAS and I forget the order of operations. So I always just, whenever possible, to disambiguate, I just do parentheses. And that just makes it crystal clear that we're going to raise the radius to the second power, and then we'll multiply pi times that particular unit. All right, so now we've written the program. And let's go ahead and run the program. I can do that by clicking on the run button, and it executes the program. And we have the answer down below, 3.1519, which is what we expect. If the radius of a circle is 1, 1 squared is 1, and so the radius of a unit circle is pi, which is what we expect. Now let's just change this to let's just do 2.5 and run the program again. I will clear the terminal window and run it again. And so the area of a circle with radius 2.5 is 19.63. Okay, now let's modify this program a little bit. We have these digits. We have 7 decimal places. It's very unlikely that we have our calculation has that degree of certainty or significance. So one of the functions that we can use is it's called round, and so we've added a function, or we've wrapped our calculation pi times r squared inside a function called round. And when I hover over it, it gives me a little bit of information about what it's expecting. So this is a function that takes arguments, 2 arguments. The first argument is the number that I want to round, and then the number of digits that I want to round to. So we're going to round the calculation to 2 digits using the round function. That's a built-in Python function that we're going to utilize. And now let's just go ahead and rerun the program. And now we get the answer with 2 digits or 2 decimal places, 0.63. Now if I change it to 3, I would get 3 decimals and so on. Let's make a couple more modifications. Suppose we want to calculate the area and perimeter of a circle. So now we're going to calculate both the area and the perimeter. We still need pi. We still need the radius. Let's change this back to 1 just to make sure that the first time we run it, it's what we expect. We don't have to change calculating the area of the circle. Let's calculate perimeter of the circle. And that's the formula. Perimeter equals, let's do the round a little bit later, but what's the perimeter of a circle? It's 2 times pi times the radius, right? And now let's also round this to 2 digits. So we've calculated the perimeter. And now we want to print 2 things. We want to print the area and the perimeter. All right, let's keep our fingers crossed and run this program and see what we get. Okay, so it looks right. So let's run it one more time. So we get 3.14 for the area and 6.28 for the perimeter. Okay, now we'll make one more change, and that's we'll get a little bit fancier with our printing format, because if you're just outputting 3.14 and 6.28, it's hard for the person who's looking at the results of your program to understand what these mean. So we're going to modify the print statement here, and we're going to print out. Let me do this in stages. So we're going to print out a string. The area of a circle with radius, and I'll explain this in just a minute. The area of a circle with radius is, and we're going to put an F in front of the string. I'm going to run this and then explain it. And let's just change the radius now. So now I get an output. The area of a circle with radius 2 is 12.57. Okay, far friendlier. Now what's going on here? Let's do the same thing for the perimeter. We want to keep the radius the same, but change. Okay, so now let me explain what's going on. So we're formatting the print statement, and this is the syntax. F, we say print parentheses. F means I'm going to format a string and then insert a variable inside that string. So it's going to print out exactly the area of a circle with radius. Here, a variable will be inserted. Hopefully there's a value that it's picked up from above. And then in where you have squiggly brackets area, it will insert the value for area. Right? And the same thing, perimeter of a circle with radius. Here, whatever the value corresponding to radius, it will print that out. Now let's run that, and now we get, so what went wrong here? That doesn't look right. Okay, so this is actually going back to our topic, primitive data operations, primitive data types and operations on those data types. So in the previous session, we looked at from within VS Code, when you're in the terminal, invoking, going into the Python interactive interpreter. And on a Macintosh, you can do that using Python 3. And then I think in Windows, you have to type just Python. When I type now Python 3, now in Python, and the way I know that is you have the chevron signs here, and that indicates that the Python interpreter is ready for you to give it commands. All right, so now let's kind of go over the basic data types, the primitive data types that we talked about. So we have a non-decimal number such as 35, and it's 35. But if we ask it for its type, it comes back class int. So it's a data type is integer. If we say, what's the type of 35.32, we get back float. If we say type, what's the data type of this object, abracadabra, it's type string, abbreviated as str. And then type, let's do false, and that's of type bool or boolean. Now we can perform various operations, and you should try and practice some of this stuff because it's not always going to turn out to be what you expect, but you should play around with operations on those primitive data types. So 33 raised to the second power is 1089. Okay, that's pretty clear. Then we have 33/4. That's straightforward division. But now if we do 33 floor division, we get back 8. So how many times does 4 go into 33? And then 33 modulus 4, we get the remainder. Now, the modulus operator typically only works for integers. You're going to have some problems if you're trying to perform operations on float with the modulus operator. But that's you want to just play around with it just to see what the results are and is it what you expect. Let's go over the operators for strings. These are the two basic operators for string. Alfred is my first name, and let's concatenate or add Essa. So I get back a string with Alfred and Essa. If I wanted a space, I would say Alfred, or I could say, it's not the only way of doing it, quote, space, plus, okay. And now let's do a variable called first full name equals first name plus last name. Now let's just print full name. And as expected, we don't have the space, so let's modify full name so that it's first name plus space plus last name. And now let's print a full name again. Now I'm going to do, if you use the up and down arrows, you can retrieve previous commands, so you don't have to type out the whole thing. And so now we have the name Alfred Essa. Okay, do one more. If I have first name times, so first name is a string, times 3, I get back, concatenate it for first name 3 times. It's kind of like multiplication. Let's look at Boolean for the moment. Booleans from last time arise in the, let me exit out of Python for a second. Okay, so typically Boolean will come up when you're doing some sort of test or condition. So let's look at that. Let's ask, is 2 less than 4? It's a comparison. Less than is a comparison operator. And the result back that we get is true. If we say is 2 greater than 4, it's false. Is 2 equal to, now we're comparing, the 2 equal signs is a comparison operator. We're comparing 2 with something else. So let's compare that to the string 2, and it'll say it's false, right? What about false? Is false the same thing as false? That's false. How about false not equal to false? Okay, that's true. Give you a couple more. What about true and true? That's true, right? These are the truth tables. If something is true, if A is true and B is true, then both combined is also true. What about true and false? Well, it's false. For a conjunction to be true, both things have to be true. If one of them is false, then the entire statement is false. What about true or false? That's true. And false or true, that should also be true. False or false. So we're just going through truth tables. All right, so I will stop here with the coding part. Let's exit out of Python. We're back in the terminal window. Let's get out of VS Code. Go back to my slides. All right, so we're at 8 o'clock Eastern, so I will let you guys go. Thank you for joining, and see you on Discord, and hopefully see you next week. All right, take care. Have a good evening. Bye-bye.